in a way, arrays are somewhat similar to normal variables, but they are they obviously do come with their territory because some restrictions exist, and so array of strings will look like this. I really like this. You know, we have a series of names, we have an array of strings, then how many strings? 5, and then each individual element in this array from 0 to 4, altogether 5, is initialized with a particular string. Unless you do this, the element remains uninitialized, right? And so we will be in trouble if we try to print that name, which was never initialized or assigned. But the true picture in memory is that in case of array of objects, and string is an example of an object, no longer a primitive data type, the array that gets created is an array of references, array of reference variables to objects, and therefore those actual strings are put aside and allocated elsewhere in memory. Inside of our array, we have references to these objects. So when we just execute this first line, none of these objects exist. All these elements inside of our array will be initialized to null. As we know, null keyword in Java represents reference to non-existing object. And that's exactly what this first line does. Once you create an array of strings, because it's an array of objects, right? In reality, it's an array of references to objects. And those references will be stored in our array and initially all set to null, to say that our array contains potentially 5 references to strings, but none of them actually is being assigned. Okay, moving on. So array of objects. Another example is that if you have some class in your application, you can now create arrays of these objects, right? So what happens is that when we say, let's say we have defined class name product, price, description, code, all these demo elements, components of that class exist in a single instance. But when we say, let's have an array of products, then the array, when we talk about this array, the array object will not contain instances or objects of class product. It will only contain references to these objects. So therefore, when I say, let me have this array of 5 products, none of the products are created. It is only the placeholder, similar to this, is created with references all set to null. Again, this is different compared to array of primitive data types. With arrays of primitive data types, the actual data variables are stored in the array. So array elements can be accessed through this. Just like we could use variable name in this kind of scalar situation where there's no array. In this situation with essentially a collection of something, array syntax, array type of collection, allows us to access individual elements, again, by using the square bracket syntax. Square bracket and provide an index. Index can be integer number between 0, including 0, and less than the size of an array, because the last index is 1 less than the actual size of an array.
Question?
Yes, question.
Maximum size of an array?
The maximum size of an array you can find out from the library. There is a limitation. Yes, there is a. I would assume. Good question. You need to dig up the documentation and find. We can do it. We can do it next week to find what the maximum size of an array is. There's a class in Java library which will tell you, which will give you that number. That number is predefined, and you can find out what is the maximum number, the maximum size of an array. But it's in the range of millions a couple of millions, I think, elements. All right, so again, examples of using the syntax is that now you use the name of an array and you use the square bracket syntax with index, which is supposed to be inside the range of an array, not not offending the boundaries. And now you can use it as a normal variable. You can just use it. And when you talk to your objects, in case if it's an array of objects, you're using references to your objects. So it's sort of very consistent with uh, kind of very consistent with normal variables. Um, Array elements example. So when we create this array, this is what we get. This little slide here indicates that when you use primitive data type to create your array, obviously, array of integers, then Java uses each element as the placeholder for that integer. It's not any sort of indirect access to that integer. This integer will reside directly inside the array object. So it's managed, its space is managed by the array object. Which brings us to the next point of discussion is that the size of an array that you specify initially cannot be changed. So if you need an array of 20 integers, say you try to store 10 integers in this array, and you ran out of space. Now you have to store more integers. Well, guess what? Can't do. You cannot resize this array. All you have to do, perhaps, is to create brand new array of, say, 20 integers to double the size of your arrays, and then move the from the old array to the new array, move all of your data. This is the limitation of an array object, that its size is fixed once created. You can use a variable here and say, ask the user, how big should it be? But once created, beyond that point, the size of an array is fixed. Cannot change that size. Yes, question?
So if you're building the array, you'd want to find out what's the largest amount of objects I intend putting here.
Absolutely. Absolutely.
You can always have it too big, but you can never have.
Well, the answer to that, like, how do we deal with this limitation? What should be our assumption? What's our strategy? Fortunately, in Java library, there are classes that represent dynamic arrays. For example, array list. That's an array that's a class that behaves as a flexible array, dynamic array. It can grow and shrink.
So if you were trying to keep track of, like, all right, say I use a 6-sided die, my possibilities are 12 numbers.
Mm-hmm.
If I use a 12-sided die, my numbers.
Mm-hmm.
So I'd use a flexible in there.
No. In our case, we're going to use the maximum. The possibility is to trash the old array and produce the new array with the size that we need each time. Each time they change the number of sides. Just basically create brand new array of that size and trash the old one. Forget what the old one does for this homework. That's actually a very good point, and at some point I may remember to demonstrate it. But so I just wanted to introduce that homework to make sure that we immediately put ourselves into the context of collection, the need for this type of storage, and now we're looking at it in terms of its syntax. The syntax is very simple. By the way, once created, you can display. Let me demonstrate this. You can get to your array size. So the array, such as three strings, three strings, provides a public data field length. It does provide a public data field length. Notice this is not a method call. This is just a field, the data, public data that's available in the array. And this length is uh, immutable since the creation of an array. So I created an array of three strings, and this number of my three strings will always be 3. However, of course, someplace else I can say, well, forget about that three strings. I'm trying to type, and instead use a string, an array of 13 strings. Well, guess what? I'm losing connection to this entirely. This will no longer be acceptable. All of these classes will be garbage collected, and I'm now creating a brand new array of 13 strings. So that is a possibility to reassign array reference to create brand new array and forget about the old one.